make this triangle. Starts out with 1. Next row, 1, 1. Okay, each row, it gets bigger. So that 1s are always on the end. Then you add these. So 1 plus 1 is 2. And then a 1. Okay, so it starts with a 1. 1 plus 2 is 3. 2 plus 1 is 3. 1. This is 1. 1 plus 3 is 4. 3 plus 3 is 6. 3 plus 1 is 4. 1. Do you guys see how I'm making those rows? So if I said x to the 0 power, so the first row is like the 0 power. Anything to the 0 is 1. Second row, if I said x plus 3 to the first, okay, you get a 1x and 1 3. If I said x plus 3 squared, so what it does is it starts out, this is like x squared, x to the first, x to the 0. This is 3 squared, 3 to the first, 3 to the 0. So then that's 1x squared. 2 times 3 times x would be 6x. 1 times 1 times 3 squared is 9. So if I asked you to do x plus 3 to the third, so this is x to the third, x squared, x to the 0. Your 3's come from this way. 3 to the third, 3 squared, 3 to the 0. So 1 times x cubed times 1 is x cubed. 3 times x squared is 9x squared. 3 times 3 squared would be 27x. 1 times 3 cubed is 27. So it's a cool little trick. I don't know if it really saves you all that much time, but it does help. If you had a higher power, it would be more beneficial. But that's really the only shortcut for multiplying that kind of thing out. Yeah.
On 16B,
Mm-hmm.
is it, so I use the second one, the x squared if, or what, does that not work because it's not approaching it from one of the sides?
Right. So because -1 is a breaking point, okay, you could even draw a graph if you need to, but we can see if we're less than -1, we're on the first piece because we don't care what happens at -1 just as we approach it. So because -1 is in between two steps, we have to do the limit from both the left and the right. So the left would be less than -1, so that's your -x minus 2. So if you put in -1, 1 minus 2 is -1. From the right, you're on the middle piece, so x squared, so that's -1 squared, which is 1. Since those don't match, the overall limit does not exist. And you could also make a graph if that helps. Should we just talk through some of the strategies we used on this? So like the first one, looking at a graph, can you guys tell me limits from a graph? And you understand the difference, question F and question G, I wasn't asking limits, I was asking the actual point on the graph. So we're okay with that? When you start evaluating the limits, if you can plug in and not get 0 on the bottom, it's legal to just plug in. So like question number 4, you can just plug into that. You don't have to do anything special. Question number 14, we're just multiplying things. So we can just straight plug in from the beginning and simplify that. When you have questions where you're getting 0 on the bottom, so like question number 3, if I look at that one, what would I have to do? If I plug in my 4, I get 0 over 0. So what's our strategy on those types? Top and bottom. So the top you can take out an x, look for GCF. Bottom we can factor nicely. You might have to do slip and slide if it didn't work out perfectly. Multiply -4 and add to -3 would be -4 plus 1. So these cancel. You need to make sure that you are writing limit on every step until when? The moment you plug in, then you drop your limit. So we get 4/5. So factoring and reducing is a very helpful strategy. Question number 10 that we talked about. Multiplying that out so things cancel is a very helpful strategy. If I look at number 8, so I always check to see, can we just plug in? Okay, if I put in 1, I get 0 on top. 9 square root of 9 is 3, minus 3 is 0. So can I plug it in? No. What is the strategy on any problem involving radicals? Conjugate. Square root of x plus 8 plus 3. Okay. I am not going to distribute on the top because I'm hoping some things cancel out. On the bottom, go ahead and FOIL. When you multiply those, the square roots drop and you just get x plus 8. Because they're conjugates, outside and inside cancel. Negative 3 times 3 is negative 9. Notice I'm writing my limit on every step. I have not dropped it yet, so I need to keep it. So on the bottom I get x minus 1. What happens? Those cancel, and now we can plug in. So now I drop my limit symbol. So we get 3 plus 3, or 6. Okay, so multiplying by a conjugate is a good strategy. The only other strategy I think we used on this was about question 7. Can I just plug in my negative 2? No. So we have to do what here? Common denominator. You kind of did that on question number 12, except that one was pretty easy to put together. But if I want to get a common denominator, this has to get multiplied by 2 on top and bottom. This one gets multiplied by 2 plus x on top and bottom. Still writing my limit symbol. So we have x over 2 times 2 plus x minus 2 plus x over 2 times 2 plus x. These denominators are the same, so we can put them together. If you distribute that negative, the 2's drop. How do you divide fractions? So we have x times 2 plus x over negative x. Now, what happens? Those cancel. So this would just be a negative 2 times 2 plus negative 2. And we end up getting 0 there. Any questions on that? Okay, so those were pretty much all the rules we used here. Also on the quiz, I told you there would be a squeeze theorem. So if I asked you to find like the limit as x approaches 0 of the square root of x squared plus 4 cosine of x over pi. How did we begin these? So then we can change the angle to whatever we need. Then we can multiply by this radical, which is legal because it's a square root, so I know it's a positive number. Then what do? We add our limit to every piece. So our limit laws allow us to plug that into the square root, so I get the opposite of the square root of 4. This was a bad one, it doesn't work. This is why I don't make up problems off the top of my head. But if I plugged it in here, we get the square root of 4, which is 2. So here, did I get exactly what it equals? No, but I do know it's now something between -2 and 2. Most of the time, those two numbers turned out to be the same, so that you knew exactly what the limit was. In this case, all you could tell me is the limit is some number between -2 and 2. All right, any other questions before our quiz? The only other thing on it, we talked about average versus instantaneous velocities. Remember, average velocity is just what? The slope. So you have to get 2 order pairs, find the slope between them. We did one of those Friday, I think. And instantaneous is like when you have the table. What is it approaching? So what are those average velocities getting close to? Anything else? Okay, then I think we are ready. I will take your homework. All you need is a pencil.